Okay, so today we're going to start something a little different with our proportions and our ratios. And it's something to do with that similarity that we were talking about in class. And today in your math notebook, you're going to write in the date and you're going to write in similarity transformations. So that's what we're going to do. We're going to work with shapes, polygons that are similar, and we're going to look at a certain type of transformation. So this is something to put in your math notebook. Similarity transformations. So the main ideas here are knowing after this video, hopefully you have a better idea of what a dilation is, what a scale factor is, and then based on that, what it means to enlarge a polygon or reduce, a reduction. So here are 4 items that I'd like you to kind of have a little idea of before you come into class tomorrow. So to start with, dilation, what comes to my mind right away is when you go to the eye doctor, and then sometimes they'll end up dilating your eyes. And your eye could go from being, if I draw on here, your eye could go from, here's your eye, and then it could go from being really small to all of a sudden really big, and you have a hard time seeing. Your eye gets dilated, so that here is called an enlargement of your pupil. And we're going to look at it within shapes. So if we look at the actual mathematical definition here, a dilation is just a transformation, and you might be like, well, what is that? In which a figure and its image are similar. Okay, so you might have no clue as to what that means until you see an example. So feel free to not write out that definition until you see an example, and then you can kind of have a better idea of what the heck a dilation is. But it's some sort of transformation in which a figure takes on a transformation in which its image, the thing it morphs into, is similar. Okay, so a dilation is 2 figures in which they're both similar. Then, something else I wanted you to have an idea of is the scale factor. And scale factor is going to bring in our idea of ratios. So a scale factor is just a ratio. The length of the image, so I'm going to put image length, to the corresponding length in the original. Okay? So that's super important, and you'll see what I mean in the examples. So if we take a look at this one here, you can just write out example 1 in your notebook. It says the blue figure is a dilation or transformation of the original figure. So my original figure must be this one on the outside. Okay, there's my original, and it got transformed. It got transformed into this blue, into that blue little triangle. But what we know, if it says it's a dilation, we know these 2 are similar. And now it's asking, well, what's the scale factor? Well, scale factor is a ratio. We're going to compare the 2 in a ratio. So we need the length of the image. Now the image is what it morphed into, this. So let's say I could look at any of these sides, but I'm going to look at either the vertical or horizontal. So if I look here, this has a length of 1, 2, 3. So I'm going to say the image has a length of 3 units. And then the original has a length of 1, 2, 3, 12. So the scale factor that's being used here, the dilation, is, if I simplify this down, 1 to 4. So let's see if it works on the other side here. If I would have used this side, that has a length of 1, and then my original has a length of 1 to 6. These are supposed to be the same. And I will say that the reason why is because now I'm looking, this blue guy goes a little further than just 1 unit. So it's really not just 1 here. So I wouldn't use that side because it would be a decimal and I'd have to approximate. And I wouldn't end up using this side because it's along the diagonal and I can't count from here to there. So that I don't want to choose this side. So this is the only reasonable sides to use to get my scale factor. Let's look at another one. Okay, so now we're going to look at each dilation. You're going to tell me whether it's an enlargement or a reduction, and you don't even know what that means, but maybe you have a guess at what you could say it means. So let's start at number 8. The blue figure is a dilation of the original figure. So here I know the original is this smaller triangle. And the dilation, it gets morphed into the blue. So I can tell which one do you think it is, enlargement or reduction. Well, it got bigger, so it's an enlargement. Okay, and then I need the scale factor. And scale factor is going to be the image versus the original length. So let's go to the image length. So let's just say I take this side here in the original. It's 1, 2, 3, 4, 5, 6. My image, 6 units. And the original was 2. So if I reduce that, it's 3 to 1, or 3 to 1, or 3, a scale factor of 3. An enlargement by a scale factor of 3. Okay, let's look at number 9. This one, remember the blue figure is the dilation of the original. So the original is on the outside here. It got smaller, so I'm going to say it's a reduction. And then I need the scale factor, so I need image versus original. The image, I'm just going to go straight to this part, has a length of 2. And then outside here, corresponding side has a length of 4. So my scale factor is 1 to 2, or 1/2. And if you actually were to use this side and compare it to the original, it would be the same, 3 to 6, which is the same thing, 1/2, or 1 to 2. Number 10, blue figure, dilation of the original. Here's my original. Okay, if my original's there, what happened, enlargement or reduction? Enlargement, got bigger. Okay, and then I need the ratio. So if I go to the image, it only gives me this length, so I'm going to go here. The image length is not 2, but 4. And then my original had a length of 2. So if I reduce that down, it's 2 to 1, or 2 to 1, or a scale factor of 2. An enlargement by 2. This one was a reduction by 1/2. This was an enlargement by 3. So something to keep in mind with these things is the general idea that if you have a dilation, an enlargement scale factor, the scale factor is going to be greater than 1. That's when you know you have a dilation that's an enlargement happening. If you have a scale factor in which it is less than 1, then you're going to know you're dealing with a reduction in the dilation. Okay? So we're going to practice with these dilations tomorrow in class. And so you'll feel more comfortable with those, and we'll probably relate it, we will relate it to the coordinate plane with x and y. Plot some points, figure out if you think it's a reduction or enlargement, and what the scale factor would be. Keeping in mind that enlargements are going to be greater than 1, reductions are going to be less than 1. You might say, well, what about if it's 1, a scale factor of 1? Well, then you have the same figure, like exactly the same, they're congruent. Okay? All right, see you tomorrow.